promised, here's the video for lesson 1.3. So what are the goals of this lesson? Well, after this lesson, you should be able to recognize trinomials in this specific form. So the form that we're going to talk about today is x squared plus bx plus c. And what we'll notice is that the reason why it's important to recognize it is because we want to be able to distinguish it as different from these three that we've already seen. Okay, so we've already seen these three forms in a previous lesson, and we want to be able to recognize this form as being different and as being, x squared plus bx plus c, as opposed to anything else. The second thing we want to be able to do is we want to be able to factor x squared plus bx plus c. What does factoring mean? Well, factoring is when we write a polynomial as the product of polynomials. So let's just make note of that. Product means multiply. Okay, so basically what I want to do today is be able to write x squared plus bx plus c as the product of two things. And we have to figure out what those two things are. Okay, so first, let's take, and the way we're going to do that is we're going to do this using patterns, very similar to the way we use patterns for a squared plus 2ab plus b squared and things like this. Okay, so today we're going to talk about patterns. Now, one thing I want to mention before we get started is that x squared plus bx plus c, okay, the way we know it has this form is that the coefficient of x squared is 1. Okay, and then we have these two coefficients, or we have b as a coefficient of x and c as a constant term. Okay, but that is how we really recognize this form of x squared plus bx plus c. Okay, so it's all a matter of the coefficients of x squared and x, and that the constant value c is there as well. Okay, so let's just look for a pattern, and we're going to do that by expanding. So what I'm going to do is expand these two, and then we'll take a look at the pattern. Okay, so the first thing I want us to notice is that the expansions, the results, are all in the form of x squared plus bx plus c. Okay, because we can see that the coefficient of x squared on both of these is 1. Okay, and then I can see that 8x plus 15 and x squared plus 10x plus 9, they both follow this pattern. Okay, also what I want us to see is the relationship between factored form, okay, or maybe not the relationship, but we know that this is factored, whereas this is expanded, right? This is factored, this is expanded. What do I mean by that? Well, if I were to take this and put it and rewrite it as x plus 3, x minus 3, well, I've written a polynomial as the product of polynomials. So the reason we're trying to figure out this pattern is I want to, again, I want to be able to give you a question like x squared plus 10x plus 9, and I want you to write it this way. So we need to figure out a pattern in order to be able to do that. Let's now look at C and D, and maybe the pattern will become a bit more clear. Okay, so let's have a look at all of these together. And the reason why I use variables for question D is because I think it makes it a little bit clear about how these variables impact how the numbers in the binomials impact the expansions and the coefficients that you see in the trinomial. For example, let's have a look at the form of this trinomial. We can see that it still does have the form x squared plus bx plus c, doesn't it? Right? Even though m plus n, we have to add those together to get our b term, it has that form. So I can see that when I expand x plus m times x plus n, I still get x squared plus bx plus c. Now what I want us to notice is the relationship between m and n in the binomial, okay, and the coefficients of b and c. So what I can see is that, well, if I look at this last term here, m and n, I can see that actually c is the product, the last term is the product of m times n, right? Just these two. And I can also look at the middle term here, and I can see that what I'm doing to get my b term is I'm adding m and n together. Okay, so b is the sum of m plus n. So if we look back at questions A, B, and C, I can actually see that as well, right? If I take -2 and I multiply it by 7, that gives me -14, which is that last term. If I sum them together, so this product, this is the sum. If I sum them together, I get 5, which is my b term, my middle term. Let's have a look at these other ones here. So x plus 9, x plus 1. Well, if I take 9 times 1, I get 9. That ends up being my c term. And 9 plus 1 equals 10, which is my b term. So I'm beginning to see what we want, a pattern. Okay, and what that should help me do is be able to take a binomial and rewrite it this way. Okay, so we're going to use the pattern to help us rewrite our polynomials. So let me just restate that. So it's all here in this box. So if a trinomial in this form, x squared plus bx plus c, which we now know how to recognize is factorable, we can write it as the product, and remember, product of polynomials means factoring, where m times n is c, so c is referring to this c, okay, and m plus m is b, referring to this term. Now, the whole mystery of this is you have to find, okay, the values m and n. And once you find these values, you can actually write out this statement, x squared plus bx plus c equals x plus m times x plus n. Now, it's going to take you some time to learn how to find m and n, but once you get really confident in it, you'll know that if you're searching for m and n and you cannot find two numbers that multiply to c and add to b, what that means is it's not factorable. Okay, so the key here is you need to be able to practice this to really recognize things that are not factorable. Let's try this one. Okay, we're going to factor each trinomial. Okay, and remember that what factoring means is I want to be able to, first of all, we can recognize that this is in the form of x squared plus bx plus c. Okay, what this means is I want to be able to write x squared plus 7x plus 10 in the form of x plus m times x plus n, where m plus n equals b and m times n equals c. So in this case, m plus n equals 7, which is my b term here. Okay, and m times n equals 10. So my c term is this one. All right, I think we're getting. Okay, so if I were to just, look at this for a minute, I can probably figure out that if m equals 2 and n equals 5, that works, right? Because 2 plus 5 is 7, and 2 times 5 is 10. So I actually know that my m value and my n value are 2 and 5. So what that means is my answer is x squared plus 7x plus 10 equals x plus 2, x plus 5. Okay, and if I'm not confident in that, I can always expand. Okay, so if I want to check my answer, if I want to check, what I'm going to do is expand. Which is right. So I know I've done it right. Now, if you don't have a great feeling about this, okay, what we're going to do is figure out a bit of a technique for this. Okay, so there's a technique you can always use to figure it out. Figure out the values of m and n, if they do exist. And the technique is called a product sum chart. And this is how it works. Okay, so let's have a look. So when I look at x squared plus 11x plus 24, I can see my b value is 11, my c value is 24. So what I need are two values, m and n, such that m plus n equals 11 and m times n equals 24. So that's key here. Okay, but here's our little technique. So the first technique is we start with the product. Okay, so this one's obviously the product because it's multiplication of m times n. We start with the product of 24 and then we write out a factor tree. Okay, so what are all the things that multiply to 24? Well, kind of a lot of them actually. Okay, so once you do a lot of these, you won't have to do this, do all this work. But what I'm going to do now is my second step to this is I'm going to sum the tree, sum all the factors in the tree. So here we go. Okay, and the last thing I'm going to do is I need to compare this to the one that I want. So I can see that I want my sum to be 11. Okay, so basically I'm going to look here and I can see that this is the pair I want. Okay, so essentially what I can think of are these are like potential m and n values. Okay, but the only m and n values that work are 3 and 11. All right, so I'm going to say m equals 3 and n equals 11. So I'm going to write my answer here, x squared plus 11x plus 24 equals x plus 3, x plus, sorry, not 11. This should be 8. All right. So guys, what I want you to do now is try all these independent practice problems. I'm going to solve them all in the video, but it's better for you to try them first and then watch the video after and just check your answers. So please right now, can you pause the video, try all the questions, and then when you're done them, you can have a look at my answers. Okay, good luck and see you soon.